Hey guys, Mr. T here. This is another video. This one's on relations. So mathematical relations, obviously. So when two different variables are connected in some way, they're said to have a relation, or a relationship, or a function. We're going to get to the idea of functions later. But yes, relation or a function, and those are ways to describe the connection between those two variables mathematically. So let's have a look at an example, because these are pretty tricky ideas that we need to get through to start off with. Let's say this table below that shows the cost of sending packages depending on their weights. So the weight in kilograms, if it's 1 kilo up to any weight less than 2 kilos, then it's going to cost you $5. From 2 kilos to any weight less than 5, it's going to be 8, and so on. So clearly, based on that table, there's a connection between the variable's weight and cost. It's not a linear one because it stays the same cost for a certain weight, and then the cost jumps up to another set costs for a certain range of weights. It's not just going up as the weight goes up. So clearly there's a relationship with it, but we haven't done any maths that allows us to deal with this sort of complicated relationship here. But like I said, there's clearly a relationship between the variable's weight and cost. Any weight between 1 kilo and 2 kilos is going to cost $5, and so on. So if I was to actually graph this relationship with the x-axis as weight and y-axis as cost, forgot to underline this, it would look a bit like this. So kilos along the bottom. So it's going to be $5 for the first one, but it's $5 from 1 kilo to anything less than 2, so it's going to be open circle at 2. It's going to be $8 next, 5, 6, 7, 8. $8 from 2 kilos, so including 2, up to less than 5. So the graph isn't just going to be like a straight line like this, like we've dealt with before. It's going to be like it's a stepwise graph. This is what it's called. So from 5 kilos to less than 10, it's going to be $12. So 5 kilos to less than 10, up to there. 10 kilos to less than 15 is going to be $16. And then lastly, 15 kilos to less than 20 is going to be $20. So here we've used a graph with the x and the y axis to represent this relationship, because obviously there's a relation between the weight of the parcels and the cost it's going to take to send them. So overall, a relation in maths is any set of points that connect two variables. What does that mean? Well, if you look at these lines here, there's points that lay on those lines. What's a point that is on this relation, or that agrees with this relationship? Points on this graph that also fit the relationship between the variables include, well, this point here is going to be 1, 5. The next point, if I was to, let's say I was to consider that point, that is 3 across, and it's 5, 6, 7, 8 up. That's another point that fits on that relation. This is another point that is at 4, 8. This is another point here, that's 5, 6, 7, that's at 7, 7, 12, and so on. I could choose any point that sits on these lines, and remember, lines are just an infinite number of points that would satisfy that relationship. So a relation in maths is any set of points that connect two variables. So this and so on is the relation. between weight and cost. Alright, so now that we've discussed what the idea of a relation is, we need to talk about some definitions here, which are domain and range. The domain and range of relation are important things to understand because you will be dealing with them in high levels of maths. So the domain, what's the domain? The domain of a relation is the set of possible values that x variable could have. The range of a relation is the set of possible values the y variable may have. And now, when you're defining the domain and range, there's certain specific ways to write down the domain and the range that you're just going to have to follow because that's what's acceptable. So what you'll notice is the domain and the range are always written in these curly brackets. Why? Because they mean the set of all. So essentially, if you've written the domain and range in the set of curly brackets, you're saying the x values can be the set of all blah blah blah, and then all of this stuff that you write after the x and this line, which means such that, defines what values x can take in the domain, or what y can take in the range. So if I was to write this, what you've written is curly brackets means the set of all. This x stands for the x values. The line stands for such that. And then what we've written here is that x can be between 1 and 5 and includes 1. So if you've written that, you've said that the domain consists of all real x values, shown by that, such that, shown by the line, 1 is less than or equal to x is less than 5. So x is between 1 and 5 and includes 1. In other words, so maybe in a simpler form of, a simpler way of saying it, the domain is all values of x between 1 and 5 including 1. That's my way of thinking about it. This is very proper up here, but that's how the book shows it. You might as well learn how to do that. Sometimes x, the x values or the domain or the range can be infinite. It can be any number. It's not just going to be between 1 and 5. It might be any possible x value because the graph goes on, or the relationship goes on forever. So in that case you would write this, the curly brackets again, because it means the set of all x such that x, and then this looks like a capital E, a curly capital E, and then a blocky R. Those two together means all real numbers. So if you were to write this, means that the domain consists of all real x values, and that's it. The domain is all values of x that are real numbers. So real numbers are any negative, any positive numbers. You're only going to have to deal with non-real numbers, imaginary numbers. If you were to do specialist maths, they're the square roots of negative numbers. Nothing to worry about that right now. So let's practice using these domain and range notation methods, because that's the first kind of questions you're going to have to answer. So if we were to look at this graph here, we want to write the range and the domain of this graph 1. So what you notice is the heads of the points of the line are arrows, so they go on forever. So that side is going to go on forever, and if I keep drawing, it's going to go across and across and across and across. So this is the x-axis, this is the y. It's also going to go across and across and across on the other side. So x, the set of all x, such that x can be any real number, because it's going to go on forever in the left direction and the right direction. So it's going to be infinitely down the negative side of the x-axis and infinitely up the positive side of the x-axis. So there's no limits there. So that's a usage of the all real numbers domain. So that's the domain. Then the range is about y-axis. So y, we'll draw a better curly bracket there. The y values can take anything up to and including, what's the y value here? 4. So So y is going to be less than or equal to 4. It's not going to go above 4. So that is the range. Alright, because the range is the possible y values. So I've said here, I've looked at the graph, all the possible x values of the points on this graph go on infinitely. They can go all the way there, all the way in the right direction. So the domain is going to be all real numbers. But the y values have a limitation. They only ever go up to 4. And then they go infinitely down that way. So y is going to be any number less than or equal to 4. That's the range. Let's have a look at this next one. So this graph here, number 2, stops at x is equal to -4, but it goes on forever in the right direction, in the positive direction. So the set of all x such that x is going to be, if it stops at -4 but it goes on forever, it's going to be greater than or equal to -4. So all the x's are going to be greater than or equal to -4, so that's the domain. What about the range? Y such that, so if I have a look, the lowest number that it can get down to is here, -6, but the highest number is going to go on forever. So y is going to be not less than, it's going to be greater than or equal to -6, because it goes on forever in the positive direction, but it stops at -6 in the negative direction. So that is the range. So what you can see is that the domain and range are defining the limitations of these functions, these graphs here, sorry, these relations, these graphs here. There's some expected notation. You have to write it in this way. That's just how it's expected to be done. So yeah, hopefully that helps you out. And starting off with the idea of relations and the idea of domain and range. Make sure you do the practice exercises, and I will see you in the next video.